This section is on inequalities. So the first example, we have a compound inequality because there's two inequalities in one expression. So what we can do is we want to get the x isolated in the middle. And to do that, we have to get rid of the 5, which we can do by multiplying all three sides by 5, the LCD, or the common denominator. So times 5, and times 5. And then we can do this cancellation here. And now we have 15 on the left side, 2x minus 9 in the middle, and 35 on the right. Now we can isolate the x by adding 9 to all three sides. And we get 24 less than or equal to 2x less than, 44? Okay, and now the final step is to divide everything by 2 to get the x by itself. And that will do it. 12 less than or equal to x less than 22. That is our inequality. All right, and in order to graph that, it doesn't tell us to graph, but you may have to graph on the homework, so let's show you how to graph that. You draw a number line, 12 on the left because that's smaller, 22 on the right, and the less than or equal tells you that that should be a closed circle, so closed circle there. And the less than on the right side tells you that should be an open circle. And this inequality says that the solution set is all the numbers that are between 12 and 22. So that would be everything in between. There we go. And there is one more thing you'll need to write, is the interval notation. So the interval, you can have 12 on the left side with the closed bracket because it's including 12. The equal sign tells you it's inclusive of 12, comma, 22 on the right side, but the 22 is not included because it does not have the equal, so that's open parentheses. So this is called interval notation. So we do want three things here. We want the inequality, we want the graph, and now we want the interval notation as well. All right, next example. So in this situation, when you have a rational expression, inequality, you need to find the zeros of the denominator. So if you set the denominator, equal to 0, you should get negative 5 over 2. So that means that x cannot equal that value, because if x equals that value, you're going to get 0 in the denominator. And in math, that's a big no-no. You can't divide by 0, that's undefined. So now we know that our x cannot equal negative 5/2. The numerator, there's no zeros there because there's no variable. So you can't really set the numerator equal to 0. So this is how you would start off these problems. You set the denominator equal to 0, and then you solve. And that tells you what values are not included in the solution set. Then you want to draw a number line. And in this case, we only have one value to consider. That's negative 5 over 2. And so what you want to do is you want to test any point to the left and any point to the right to see if it should be part of the solution set. So I'm going to test, you want to test values that are easy to work with. So on the left side, I would choose, that's negative 2.5. So I would just go with negative 3 is good enough. And on the right side, I would choose an easy number such as 0, because 0 is definitely to the right of negative 5/2. So I always try to test 0 whenever it's possible because 0 is such an easy number to work with. So let's test negative 3. So if you plug in negative 3 into the original problem, you're going to get 3 over 2 times negative 3 plus 5. And you want to know whether this is true or false. So that is 3 over negative 1, which is negative 3, and that is true. Negative 3 is less than 0. So that means that this side is part of the solution set. Now we got to figure out if this side is part of the solution set. So we do the same thing. Substitute 0 into the expression. You get 3 over 2 times 0 plus 5. Question mark. That's 3/5 less than or equal to 0. That is false. So the right side is not part of the solution set. this side is part of the solution set. So I'll just put a little T for emphasis and a false for emphasis. And this would be, let's see, well, we know that negative 5 halves is not cannot be a solution, so this has to be open circle, because if you put a closed circle, that means that negative 5 halves is a solution, which it's not, as you can see over here. So we do have to place an open circle, which can be a little confusing because you might see this and think, oh, closed circle, but that's not the way it works, because this is a value that's in the denominator and you do not want it to be 0, so you have to exclude it. So the left side is true, the right side is false. So that means we're going to shade the left side. There we go. And the interval notation for that would have to be everything to the left, which is denoted by negative infinity. Infinities, whether they're positive or negative, should always be exclusive, so parentheses. And to the right, you have negative 5 over 2, and that's an open circle, so also a parentheses there. So this would be the solution in interval notation. For this one, you don't really have to write the graph. You can just the inequality. You can just have the graph and the interval notation, and that's good enough. Okay, so now we have a absolute value inequality. So in this situation, whenever you have a greater than symbol, that means you want to break this up into two separate inequalities. The first one's going to be 3x minus 9 greater than 6. The second one would be 3x minus 9. You multiply this by negative 1. And since you're multiplying by a negative, that reverses the direction of the inequality. So for the second equation, you want to multiply by negative 1, which changes this to be the opposite direction. This always stays the same for both equations, so that in the absolute value expression never changes. And then all you got to do is just solve these two separate inequalities. So you get 3x greater than 15, x greater than 5. Over here you get 3x less than 3, x is less than 1. So now we have our two inequalities which we need to graph. So if you write a number line or draw a number line, 1 is less than 5. So 1 goes on the left side, 5 goes on the right side. They're both open circles. And then this inequality says that you want all the values that are less than negative 1, which goes to the left. And then this inequality says you want all the values that are bigger than 5, which means you shade to the right. And that is the final graph. The interval notation for this is you want all the values that are from negative infinity to 1, excluding 1, union, because you have two separate sets, open parentheses 5, comma, positive infinity, parentheses, and that is your interval notation solution. Okay, for the next one we have a quadratic. So what we need to do is factor the quadratic. If you factor the quadratic, you'll get x and x, negative 3 and positive 2, less than 0. Actually, you want to treat this as an equal sign for now. If you treat this as an equal sign and you solve, you should get 3 and negative 2. So what you need to do there is you need to place those on your number line. So negative 2 is less than 3. Okay, and these are going to be open circles because of the less than symbol. So open and open. And now we need to test three intervals. We need to test the left, the middle, and the right. So you can test any values. I'm going to test negative 3 for the left, 0 for the middle, and 4 for the right. And you place them, you have a choice. You can place them into the original inequality or the factored version. Now you're going to go back and change that back to the less than symbol that it originally had. And I like to test it into the factored version personally. So I'm going to test these values into the factored version. So if I do, I should get negative 3 minus 3. Negative 3 plus 2, is that less than 0? Question mark. It's negative 6 times negative 1. That's 6 less than 0 is false. So that's false. For the 0, I'm going to plug it into the original. If you plug in 0 here and 0 here, you're left with negative 6 is less than 0, which is true. So this one's true. And then for the right side, if you plug in 4, I'll go back to the factored version. So you have 4 minus 3. 4 plus 2, is that less than 0? Well, that's 1 times 6 is 6 less than 0. That is false. So our solution set is the values that are between, not including negative 2 and positive 3. And in interval notation, that would look like this, negative 2, comma 3. That's the interval notation. Okay, now we have another rational expression in our inequality. So this one, we need to factor the denominator first and the numerator if it's possible, but in this case, it's not possible to factor the numerator. Before you cancel out these factors, you do want to cancel, but not yet. You want to wait a little. You want to draw your number line. Well, first, actually, let's find these two values that make this undefined. The two values are going to be 3 and negative 3. Notice I put cannot equals because if they are equal, then you get 0, which makes it undefined. So that is, those values are not allowed to be in the solution set. Then you do the same thing to the numerator. You set those equal to 0. Well, x squared plus 1 and x minus 3, if you set those equal to 0, this one is just going to be x squared equals negative 1. That doesn't have a real solution. This one has a real solution. So now you draw your number line. And you want to place negative 3 and 3. All right. At that point, now you can go ahead and cancel these out. And so now we have x squared plus 1 over x squared plus 3 greater than or equal to 0. And now we have 3 intervals to test once again. 1, 2, 3. And let's see, x cannot equal those values, so therefore open circles for both of them. So let's test negative 4, 0, and positive 4. So you can test them into this more simplified version because we've canceled these out. So now you can just test these values in here instead of up there. So for the first one, if you plug in negative 4, you're going to get negative 4 squared plus 1 over negative 4 plus 3 greater than or equal to 0. That's going to be 17 over negative 1. That is false. Negative 17 is not greater than 0. So this is a false. If you plug in 0, you're going to end up with 1 over 3. That is true. And if you plug in 4, you should get 4 squared plus 1 over 4 plus 3, which is 17 over 7, and that is true. So that tells you your solution set is going to be these two intervals. And we have to write that in interval notation. So if you use interval notation, going from left to right, you're going to write negative 3, comma 3, non-inclusive for both of those, union, positive 3, comma infinity, non-inclusive as well. That is the solution set. And now we got one problem. This is the final problem of the section. So for this inequality, we need to bring this term over to the left side so that we have 0 on the right side. So let's subtract over that term. So now we have x over 3x minus 5 minus 2 over x minus 1 less than or equal to 0. Okay, so now we need to combine these two fractions into one single fraction, and we can do that by getting a common denominator, which is 3x minus 5, x minus 1. And now we have to multiply top and bottom of this fraction by x minus 1, x minus 1. And over here we multiply this one by 3x minus 5, 3x minus 5. So now if you distribute and combine like terms, don't forget to also distribute the negative, we end up with x squared minus x minus 6x plus 10. Combining like terms gives us x squared minus 7x plus 10 over 3x minus 5, x minus 1, less than or equal to 0. And now we can factor this numerator. That's a trinomial that can be factored. And so that becomes x plus 5, x minus 5, x minus 2 over 3x minus 5, x minus 1, less than or equal to 0. And now we're in the situation that we were in the previous example. So we set the denominators equal to 0 to see what the excluded values should be. So I'm going to write this on a separate sheet, on a separate page, because we're out of space. So I'll copy. And let me write that on a new page. Okay, so let's start with the denominator. So if you set those two factors equal to 0, you will get x equals 5/3 and x equals 1, and that cannot equal because that would make the denominator equal to 0. So in our number line, let's see, 1 is less than 5/3. 5/3 is a little bit bigger. We need to write those as open circles because we're not allowed to have those in the solution set because that makes this undefined. All right, then we set the numerators equal to 0, the numerator factors. X minus 5 equals 0, x minus 2 equals 0, and we end up with 5 and 2. So 2 would be, let's see, 5/3 is 1.6 forever. Whoops, sorry. So that means that 2 is a little bit bigger, and 5 is much bigger. I'll extend that out a little. So 5 would be over here somewhere. And those would be closed circles because of the equal on the bottom. So those are closed circles. And now we have some testing to do. We have 1, 2, 3, 4, 5 intervals to test this time. So let's see. To the left, I'm going to test 0. That's my favorite number to test. In between these two values, I'll test 1.5. In between these two values, I'll test 1.75. And in between 2 and 5, I will test 3. And I will also test 6 to test the final interval. So this is going to require a lot of probably tedious work. But if you plug in 0, 0, 0, and 0, you're going to end up with the negative times a negative times a negative times a negative. 4 negatives makes a positive. A positive is not less than or equal to 0. So this one's going to be false. If you enter 1.5, you're going to have a negative here. 1.5, that would be a negative here. And on the bottom, you're going to have, if you enter 1.5 here, 3 times 1.5 is 4.5, so this will also be negative. And if you enter 1.5 here, that's going to be a positive. So this time you have 3 negatives, which is a negative. So a negative is less than 0 is true. All right, let's do the same thing for 1.75. 1.75, that would be negative. 1.75, that would also be negative. And then down below, 3 times 1.75 is 5.25. So this is actually going to be positive. And then 1.75 minus 1 is positive. So now you have 2 negatives, which is a positive. So a positive is not equal to 0, less than or equal to 0. So that's false. Now we have 3. If you plug in 3, you're going to have a negative times a positive times a positive times a positive. So that's 1 negative. So that is true. And then the last one is 6. So that's going to be a positive times a positive times a positive times a positive, which means a positive is less than 0 is false. So our final solution set is the ones that are true, that one and that one, and that does it. The interval would be 1, 5/3 union 2, 5, but the 2 and the 5 are inclusive, which means square brackets on both sides. That is a final interval notation.